Get started, guys. Good evening. Can everyone hear me? Okay, sounds good. So why don't we get started with just going over the homework from last week, and then we can move on to today's stuff. So I'm just gonna be going over this practice 1 part, and then I'll send the solutions for both practice 1 and practice 2. So, okay, here we go. And then while I'm working through the problem, I'll disable the chat for everyone, and then afterwards I'll open it up for if you guys have any questions. So I'm gonna disable that. Okay, and then I'll open it again at the end of each question, so that way you can just make sure we're getting through the whole question first. So here we go. So number 1, solve the equation 6.1m plus 35.6 equals 10.8. Round your answer to the nearest tenth. Here we go. Okay, so what we need to do is we need to isolate the variable. So what that means is just getting the variable on one side of the equation and all the numbers on the other. So here we go. The first you have to do is multiply both sides by 10. So that way it's just easier to work with. You're not working with decimals. So here we go. You get 61m plus 356 equals 108. And then you take the 356 to this side, and then you get 61m equals negative 228, and then you divide by 61, and so you get approximately negative 4.06, and then since you have to round it to the nearest tenth, it becomes negative 4.1. And so the answer won't be negative 4 because the question asked for round to the nearest tenth. So that means you have to round it to a number, so let's just call it n point and then one more. So something from 0 through 9. So this case, when you probably use, well, you would use a calculator for this most likely. So since it's a 6 here, anything 5 or greater, you round this to 1. Okay, so did everyone understand that problem? Okay. Why don't we move on to the next one? Okay, so solve the equation 12x minus 1.9 equals 3, and then in parentheses 8x plus 11. Round your answer to the nearest tenth. So here we go. So first things first, whenever you see decimals, multiply by how many of your decimal places there are. So in this case there's 1, so we'd multiply by 10. So then you get 120x minus 19 equals 30 times 8x plus 11. So in this step, it's like saying this top one, from here to here, it's like saying 3 times 8x plus 11. And then what you're doing is just multiplying it by 10. So when you do this, it can be written as 30 times 8x plus 11. Okay, so then what you do is you distribute this 30 and open up the bracket, or parentheses. So you have 12x minus 9, or 120x minus 19, so that stays the same. And this one, the 30 times 8x, so 240x. The 30 times 11, so you have 330. And then what you do is you have to take the x's all on one side and all the other numbers on the other. So what you do is basically they just flip flop the side. So we took the 120 this side and then brought the 330 to the other side. So we have 240x minus 120x equals negative 19 minus 330. So then you just solve both sides. So you get 120x equals negative 349. Divide both sides by 120 to make sure you get x on one side only and all the numbers on the other. You'll get approximately negative 2.9. So does that make sense to everyone? Okay, so I'm going to move on to the next one. Solve the equation 3.11x plus 14.96 equals 7.83x minus 23.41. Round your answer to the nearest hundredth. So here we go. So now we're moving from tenths to hundredths. So since we're working with two decimal places, we'll multiply by 100. So that way there's no decimal places. So you have 311x plus 1,496 equals 783x minus 2,341. And the answer to number 2 would not be 2.0, it's negative 2.9. Right there. Because it's negative 349 divided by 120. So when you actually plug this into a calculator, you get negative 2.9083 repeating. So because it's a 0 there, it just stays with negative 2.9. So that's why. When you're working with these problems where they say round to the nearest tenth, round to the nearest hundredth, you really have to make sure you know rounding and decimal places. Okay, so moving back to this one. So then this is your equation you have right here with no decimal places. So then once again, just make sure all the x's are on one side and the numbers are on the other. So you bring the x here. It's just easier to keep the x's as a positive number, the constant before it to be positive, and then, whoops, and this 241 over there. So what do we have? We have 783x minus 311x is equal to a positive 2,341 plus 1,496. So when you do all the math, you get that, which is 472x, equals 3,837, and then you just divide by 472, just to isolate your x, and then you get this answer on your calculator. So because it's a 9 here, and you think 5 or greater, you round up, so you round it to 8.13. Does that make sense to everyone? If I need to slow down, just go ahead and tell me. And slow down a bit. I just want to make sure if we're all understanding it, then you can go through it faster. But, okay, so if anyone has any questions, whether on a previous problem or the problem's answer, just go ahead and type that in. I think I'll leave the chat open for now, and then if needed, I can save it for a little while. Okay, so basically what we're doing is, wait, so is the note for you guys don't understand the problem? Okay, so basically what we're doing is, here's our problem. So whenever you see an algebraic equation like this saying solve for x and round to the nearest hundredth, what you want to do is you want to take this equation and get it in this form. X equals, and then some number goes here. So all we did was, the first thing we did was to multiply by 100. By doing so, we got rid of all of the decimal places. So now we got 311x and like 1,496 is equal to 783x times 2,341. So basically, this is the same thing as that last equation, just multiplied by 100. And then the next thing we did was, now what you want to do is you want to bring all the x's on one side of the equation. So basically, this is where all the x's go, and there'll be a number before it, and then all the numbers on this side of the equation. And so what we did then was we brought the 783x to the left side of the equation and the 1,496 to the other. So that way now we have all the x's on one side and for the most part the numbers on the other. So what we have to do now is we have to get this 472 to the other side. So to do that, we have to divide both sides by 472. So by doing so, we can cancel that, and then we get x right here. So x is equal to, and then this number. Now the question asks for us to round it to the nearest hundredth. So what we do is we just plug it in a calculator, Or if you want, you can divide it by hand, and you get approximately 8.129, if not exactly. And then the 100th place would stop right here. But you have to round it. So anything that's 5 or above on the place right next to it, you round it up. If it's 4 or below, you round it down. Or in other words, you just keep it the same. So since it's a 9, we make it 8.13. Does that make sense to everyone now? You guys can go ahead and type that in the chat box. I've enabled it again. Okay. Looks good. Okay, so basically what we're doing in all these problems is just trying to get it to this form right here. X is on one side and all of the other variables on the other. Okay. Why don't we move on to the next one? 4. Solve the equation and check the result. So there's two major parts to this. First one is to actually solve it. So here we go. So we have 7 times t minus 0.5 plus 21t equals 0. So first things first is we distribute the 7. So you get this one. So 7 times t is 7t and minus 3.5 because 7 times 0.5, and you still have the plus 21t. So now we want to get all of the t's on one side, and there's a number, and all of the numbers on the other. So we keep the 7t and 21t, we just add them together, and then we take this 3.5 and bring it to the right hand side. So you get 28t is equal to 3.5. Now we have to get rid of the 28t, so we divide both sides by 3.5, or by 28, sorry. So there we go, that cancels, and we have t equals 3.5 divided by 28. Now the question, I believe, asked for 1,000? No, okay, so the question didn't ask for any specific one. But when you actually do, so that way, whenever you're working with these, if they don't specify to what place you should round it to, then try to keep it in its exact form. So when you actually plug this into a calculator, you get 0.125. The answer to 4 is 0.125. Because they never asked us to round it, they just said solve the equation and then check the result. So by rounding it, you're going to get a slightly off answer. So only round it when the problem or the competition is asking you to. But when they say just solve it, you'll either leave it in a fraction or leave it in a decimal if it's a pretty nice decimal. And this is fairly nice. There's some pretty mean decimals out there, so that way when you check your answer, you can make sure it's the right answer. Because if I round it to 0.13, let's say, we round it to 100, when I plug this in, I won't get exactly 0, I'll get a little off. So now when we actually plug this in, you'll get 7 times 0.125 minus 0.5 plus 21 times 1.25, and then when you solve it, you'll get 0. So does that make sense to everyone, how we got there? So the answer is 1.125. And then the checking your result or your answer is the next part. Okay. So why don't we move on to the next one? Okay, so solve the equation and check the result. So I think for these next couple, all the way up to, all the way up to 8 is pretty much the same method. Here we go. Okay, so first things first is either you can distribute the 3/4 or you can multiply both sides of the equation by 4, because then it just gets rid of the denominator. Now remember, whenever you do something to one side of the equation, you have to do it to the other side as well. So if I'm multiplying this side by 4, I have to multiply it by 4 as well here. Okay, so you multiply both sides by 4, so 3/4 times 4 is 3. You still have the a minus 4 in parentheses is equal to -1. So then you distribute the 3, so here and there. You get 3a minus 12 equals -1. You take the minus 12 over there to make it a positive 12. Get 3a equals -1 plus 12, and then 3a equals 11. Divide 11 by 3 to get rid of the 3 on the left-hand side of the equation, and you get a is 3.66 approximately. I would though disagree with their rounding, because when you actually divide it, you'll get 3.6666 repeating. And so what they did was they just chopped it off, which isn't actual rounding. It's just, I can't remember the exact term for it. But when you round, you always have to look at this next place, and since it's greater than 5, or 5 and or greater, I should say, you have to round it up. So this should actually be the answer, 3.67. So the rounding in competitions, you have to be really careful, especially in the rules. Some competitions like math counts, I believe, unless the problem specifies, you always round it to the tenths, I believe. So even if you got an answer of 3 in here, always write it as 3.0 if the problem asks to round it to the nearest tenth. So that's not the answer for this, but just a little competition tip. Okay, so does that make sense to everyone? How that problem worked? These sorts of problems could be in competition. The things that we're going to be doing today, the word problems and applications of equations, is what almost all of math counts problems, well, not all. For the most part, quite a few of the problems will be using some sort of equation or some sort of problem solving. So today's topic is pretty important. And so I'll be sending, it's like, I think an 18-page document it's called Important Pages, so just like a summarized thing of the class. So that's something to keep, for sure. Okay, I just have to double check if I could send it, so. Okay, next one. Here we go. So solve the equation and check the result. Oh, so if you check the result from the last one, it'll be -1/4. Okay, so we can just skip the checking because it's not necessarily required. So 3/5 n plus n is equal to 6/7. Okay. So here's what they do. So here's where LCM comes in. Multiply both sides by the LCM of 5 and 7. So the reason you do that, so let's rewrite it so it's easier to look at, is because you want to make sure you get both the 5 and the 7 out of the denominator. And the only way to do that is if you multiply by a number that has both, that is a multiple of both 5 and 7. Now it's easier too if you multiply it by the smallest number that is a multiple of 5 and 7. And that's what it's called, the least common multiple, which we learned in the second class, I believe. Okay, so you multiply by the LCM. So by doing so, since it's 35, you get rid of the 7 and 5 in the denominator. So what you do is you have the 5 goes into 35 7 times. So you have 7 times then 21. Oops. 7 times 3n plus, now see how there's nothing in the denominator here? So that's why when we multiply the 35, it goes straight to the numerator. Is equal to, now 6 7 times 35, you can cancel the 7 in the denominator with the 35, because 7 goes into 35 5 times. So that becomes 5 times 6. Then when you simplify this, you get 21n plus 35n equals 30. And then you add that, so you get 56n, so we're right there. With 30, divide both sides by 56, and you get n is equal to 15/28, or 0.536. So does that make sense to everyone? So now all these basic things we learn, like percents, decimals, LCM, various common factors, those are all going to start appearing in these problems in the forms of equations or something like that. Okay. Looks good then. Why don't we keep moving on? So number 7. So P plus 1/4 P equals 3/4. So there's two ways you can do it. The first step is one you can add the two p's together first, so that would give you 4/4. P is the same thing as 1p. Oh, the answer to number 6 would be 15/28. The way I would leave it, I think it's just easier to leave it as a fraction. One thing to remember is fractions are your friends. Trust me, because decimals get ugly and you don't want to have to write them out, and fractions are always the exact thing. So, that's one thing to keep in mind. Fractions are your friends. Okay. There we go. Okay, moving on. Here we go. So one thing you can do is you can just group the two p terms together. So what you do is when you add them together, oops, that's supposed to be a plus sign, you get 5/4 p. So you can see how I got the 5/4 because 4/4 is the same as 1 equals 3/4. And then you can multiply both sides by 4 and keep working through the problem. Or what you can do is you can just start off with multiplying both sides by 4, but you'll get the same thing because when I multiply this by 4, I get 5p equals 3. So you can see here, the equations you're going to get towards the end are going to be the same. It's just two ways you can approach it, whichever one you feel more comfortable with. So, okay, so now we've gotten to this step, so then it just becomes the same problem. So you divide both sides by 5, p equals 3/5, which equals 0.6. So does that make sense to everyone? Okay, sounds good. Okay, number 8. So here we go, here's the equation. X by 12 minus 2x divided by 3 equals negative 1/3. I don't know if you guys can see that, but this number is a negative 1/3. The negative and the fraction mark are a little close. Oh, that's one thing when you guys are writing the problems, I would avoid trying to write them like the negative sign right next to the fraction. I would try to write it either in the numerator or in the denominator. Whoops. Because it's just easier to keep track of. And all these three are the same thing. It's just easier because when you're writing, doing homework or something like that, sometimes these two can kind of blend together and then you kind of lose the whole negative thing. So in the next step it becomes a positive, which is not correct. So just a little tip there. Okay, so first thing you want to do is multiply both sides by the LCM. Why? So you can make sure you get the 12 out of the denominator as well as the 3. That's supposed to be a 2x by 3. Yeah. Okay, so you multiply the whole thing by 12. So what do you get? Well, you get x minus 8x, because 3 goes into 12 4 times, so it becomes minus 2 times 4x. It's supposed to be a multiplication side. So that becomes negative 8x, and it's equal to negative 4, because 3 goes into 12 4 times, and you have to remember the negative. That's one thing. It can be really easy to lose track of your negative signs, so be really careful that you copy them down all the way through the problem. Okay, so just grouping these two, they're like terms, so grouping them together, you get negative 7x equals negative 4. So you divide negative 4 by a negative 7. It's supposed to be a negative 4 divided by negative 7, and the negatives cancel, and you get 4/7. So that makes sense to everyone? Pretty much the same problem as some other ones. Okay, looking good. Okay, 2 more to go. And then we can move on to today's topic, which I like a lot. So, okay, number 9. Half b plus 2/4 is equal to b minus 5/2. So, Okay, first things first is multiply both sides by 4, but I would disagree with that first step. So what I would do is, here you go. So you have, before jumping into the problem, especially when you see fractions, right away, first try to simplify as much as you can, because it's going to make the problem a lot easier. So in this case, you're just multiplying by 4, but in problems where you have like half b, and then you have plus, let's take 1024 by 2048, which is the same thing as 2/4, is equal to b minus 5 halves. Well, are you going to multiply by 2048 the whole equation? Because you're just going to get really messy numbers. So instead of doing that, I would first simplify all the fractions you can. Because 2/4 is the same thing as 1/2, so you can just go 1 by 2. So you're not going to change the answer of the equation. You're just making it a lot easier to work with. So now that you have that, you can just multiply everything by 2. So you're working with a lot smaller numbers, so it's a lot easier to see where this problem is going and make less mistakes. Okay, so we got to get all the b's on one side. So why don't we take these over here and we're putting the 5 half over here. So we get 5 halves plus a half. That's the same thing as 6 halves is equal to half b. And if you want, you can multiply the whole thing by 2. It really doesn't matter. You're just working with halves, so it's pretty nice. Okay, so this cancels out to 3 over 1. And so you get 3 equals half b. And then you multiply both sides by 2 to get rid of this half. So multiply by 2. And all you get is this 2 cancels with this 2. So you get 6 equals b. So that's your answer right here. And you'll notice this is the same exact answer as right here. It's just that we didn't have to work with quite as big numbers. So does that make sense to everyone? How we got there? Okay. Looks good. Okay, so let me go on to the last problem. Solve for x. So what you have to do is you just have to basically isolate x on one side and numbers on the other. Same as always. So, see, 5 minus 2x plus 3 times x minus 4 equals 27. Okay, I'm just making sure the problems are right. That's something. Whenever you're working with problems, make sure that when you copy down the problem, it's always the same as the actual problem. Because if it's not, then you're just starting a whole snowball effect of mistakes. So, that's something. The easiest mistake to make is copying the problem down wrong. Trust me, that happens a lot. So, okay, so let me move on. So 5 minus 2x plus 3x, we distribute this 3x, or the 3, to get 3x minus 12 equals 27. So once again, group all the x's, because they're like, so here's minus 2x plus 3x, and then you have this 5 and minus 12. So you can rewrite this as minus 2x plus 3x plus 5 minus 12 equals 27. So you group all your like terms first. So here's one set of like terms, and the other set of like terms is the numbers. So that's B. Okay, so I'll go a little slower. So basically this is our equation. So we distributed the 3, and then we got this equation right here. Oops. And then I'm just rewrote the equation. So the minus 2x plus 3x came here, and the plus 5 and minus 12 came here, just so it's easier to work with. So minus 2x plus 3x is x plus 5 minus 12, well that's minus 7, equals 27. Now we want to take the 7 to the other side, so you add 7 to both sides, so that's equal to 34. So x is 34. And this problem you didn't have to round anything, so it remains 34. Does that make sense to everyone? Okay, so I will be emailing the solutions to this, to the we just went over, as well as the solutions to the second part of the homework, the practice 2 part, in case anyone also did that. Okay, so any questions at all, anyone, on any part, whether answers, solution, going over how we got there? Because it's really important that you guys understand this, because this is the base for a lot of things in the future. So, and then I did send earlier today the little packet thing. It was almost like a summary for the notes for last class. So. Okay, well, I think we can mark this as done. So, great job on this. Okay. So today we're learning applications of equations. So here we go. So, and we're still working with equations in one variable. So just like the first class, what we're going to do is we're going to go over some word problem strategies. Yeah, if you guys need to go to the bathroom or something, go ahead in the middle, don't worry about it. Try to go before or after class or during break. And we'll take another 10-minute break today. So I think for the most part, for the rest of the time, we'll be taking 10 minutes. So in about half hour, we'll take a 10-minute break. So yeah, if you guys need to go to the bathroom or something like that, just go ahead. Okay, so word problem strategies. Here we go. Number 1. Read the problem carefully. That's the key word. Read it very carefully. Draw a picture if you want. Number 3. Circle the unknown. So all that means is identify your variables. So what are you trying to find in this problem? Pick one unknown to be x, or any other letter you want, or even symbols. But make sure it's not like a plus or a minus or something. 5. Write the other unknowns in terms of x. Write an equation. So these are just basically steps that we'll go through when solving a problem. For the most part, all these steps will just be one jumbled thing. You'll probably take care of quite a few steps in one process, but they're just identifying it. So, okay, so next one is solve the equation. That's the big one. That's going to be the majority of your problems. So. Okay, next one is plug in into the original equation. So basically it's just checking your work. And number 9, reread the question to make sure it is asking for x and not something else. So just make sure your answer actually fits back into the equation. Okay, so for this, I don't believe you shouldn't need to be writing this one down, I don't think, because I'll be sending a Word document with all of this, or with most of this in it. So I can just quickly check to make sure these strategies are. So yeah, these strategies are on it. If there's something you guys should write down, I'll definitely let you know. But yeah, so you guys don't need to write this down right now. It'll all be in the after. Word problem, these are kind of keywords that'll lead you to what your equation is going to say. So if I have any of these words right here, the sum of, increase by, plus, more than, greater than, total, that's going to lead you towards it is going to lead you to the addition side. So that tells you you need to add something. Subtract, you'll see the words are difference of, decrease by, minus, less than, lower than. So anything decreasing, so you'll see the word subtracting too, maybe. And then multiply, times, multiply by a factor of, something like that. So basically, I'm just going over these words that you're going to be finding in word problems. So there's certain keywords you need to look for in order to know what equation to make. So if I'm gonna say Sally's age, so let's just type that. So Sally's let's say something else. Yeah, Sally's share of Halloween candy plus Nathan's share of Halloween candy was 140 pieces. So what is that problem saying? It's not asking you to solve anything, but it's just showing where these words are. So you see Sally's share of Halloween candy. So yeah, Sally's share of Halloween candy. And then you have this plus right here. Plus is a keyword. So plus, you can see the plus leads you to addition. Nathan's share of Halloween candy was 140 pieces. So that's how you get an equation. And then the problem could go on, say, if Sally's share was half of Nathan's, then how much did she have, or something like that. So basically, this is how you get. So you'll see like with like plus, quotient of, that leads you to division, divided by, into equal parts, something like that. So, and these are all the words that you'll find. There's other ones too, but for the most part, you'll just see words like this. It'll be really close, or if not the same, you'll see it in the problem. So, okay, so moving on. Let's actually take some examples here. So now if we go in detail here, subtraction. So what if I were to say, so minus, the word minus itself. So if I were to say a number minus 2, so what would that mean? What that means is, so some numbers, we'll call it n for number, right here, minus 2. So see that minus leads to subtraction. So that's where, and then, so that's how you interpret that one. Now there's some where you'll have 2 minus a number. So that just means you have to take, so you literally follow the question, you almost go in order for some of these. So when I say 2 minus a number, I can literally go 2, that leads to subtraction, minus, and a number, n. So some of them are pretty straightforward, you can just read it off and write it. Some of them are a little trickier. So difference between, so what if I were to say the difference between a number and 8. So what that means is whenever you say the difference between a number and 8, the first number is always going to be the one that comes first. So a number, call that n, and the difference, so that's minus, and 8. So if I were to say the difference between 7 and a number, then I would have to do the difference between 7 and a number. Now it really matters the order in subtraction. In addition, it doesn't matter so much, but in subtraction, 3 minus 2 is most definitely not the same as 2 minus 3, because 1 is minus 1 and 1 is 1. Or, this one is 1, I should say. 3 minus 2. So that's why it's really important that you recognize the order of the numbers the problem is asking for. Okay, so next one. Okay. From. To from a number. This one's not necessarily that common, but still good to know. So, to from a number means n minus 2. We're all working with subtraction here, so all these words are for that. So, less. A number less, okay, it's usually less than, I should say, so less than. So, a number less than 3. So what that means is I have, or whoops, not a number less than 3, my bad. 3 less than a number. So what that means is n minus 3. Because I'm saying I want to take 3 less than 1 is already there. So to do that, I have to subtract 3. So then we have fewer than. So it's the same thing. Instead of less than, I'm just going to say fewer than. So 3 fewer than a number. It doesn't necessarily have to be 3 fewer than a number. It could be, it's not grammatically correct necessarily to say this, but you could say a number fewer than 3. So it could imply, when you say a number less than 3, it implies this n is less than 3, but maybe you'll see, whenever you see less than, yeah, just think of that. Don't think of, if you see a number less than 3, that's what it means. But if it's 3 less than a number, then it's that. And that's the same for fewer than. So that's where like the same thing except a slightly different order makes a big difference. Okay. So basically all we're going through is we're going through different ways to say literally subtraction in word problems. Okay. Next one. There's only a couple more, I think. Okay, 2 more. Decreased by. So a number decreased by 2. So what that means is I'm decreasing this number, so n, by 2. So I'm decreasing it by 2, so I subtract 2. Next one, take away. So take away 2 from a number. So this one's the one that's like more, it's tending towards more a visual sense of it. So basically it's the same thing as n minus 2. But it's almost like a visual sense. So say I have like 5 apples. So whoops. So you have some nice 5 apples here. And if I take away 2, well, I'm taking these 2 away for myself, let's say. So those are gone, so now we had 5 minus 2, hence the subtraction sign, and so we have 3. So basically, yeah, this one is probably the one you guys have been hearing since like kindergarten and 1st grade. If I have this many things and I take 2 away, how many do I have? So, but that one you're not going to see as much going forward. But still good to know. Okay, so any questions on the subtraction words? Yeah, this one I'm also sending out to you guys. So sending out these like more words for this, addition, multiplication. Yeah, and I think a little bit for division. No, I think division is pretty much all that I said earlier. Okay, so is everyone good on this? Okay, so we're just learning the words right now for what you're going to see in word problems, and then we'll get, so once, the main thing is to be able to identify what is the problem asking for, and so we need to know these key words so we know exactly what they're asking for, but then once we get to this we'll start actually tackling some problems. So, okay, so now we'll work through subtraction, or addition, sorry. Okay. Here we go. Addition. So we have plus, which is the same thing. So we have a number plus 2. So a number n plus 2. Literally the plus sign. And that's 3 and a number. So this one is a good thing. Addition, it can go any order, and it doesn't matter. So you could say a number and 3, and you'll still get n plus 3, or you could say 3 and a number, and you'll still get n plus 3. Added to. Say 8 added to a number. So 8 added to n. or n plus 8, either one. Greater than. 3 greater than a number. Now, these are good to know, like, in the beginning, like these greater than and less than for subtraction. But when you get on to learning inequalities, they're not so great. Because when you see n is less than 4, what that means is n, and then you'll see the less than sign 4. So don't think subtraction there, think less than sign. Or if I say n is greater than, then I get n is greater than 4. Or you'll have greater than or equal to 4, something like that. So this one, it's good to know for now, like in general, but when you get to inequalities, the wording becomes really similar, so you have to be really careful in what you're doing. So, okay. Next one. So we had greater than. Now we have more than. So 3 more than a number. So we have, and I'll be sending this all out, so as long as you guys are kind of paying attention, getting the feel for it, then we're all okay. Increase by, so 3, or I should say, a number increased by 3, and so we've got a number increased, so plus by 3. Okay, so the difference between greater than or less than. So do you mean in terms of what sign is for what sign? Okay, so the sign. So here's a little trick. So I have so I have two numbers. So I have 2 and I have 5. So I want to say 5 is greater than 2. Think of it as an alligator mouth. Now alligators like to eat big meals, so obviously they're going to go towards the greater or the bigger one. And they're going to ignore the smaller one. So think of it, whichever the alligator mouth is always going to be pointed towards the greater value. Does that make sense? It's a little analogy there. So that's how you know. Whenever you see greater than, then the alligator mouth is going to be pointed there. So basically, it becomes 2 is less than 5, or 5 is greater than 2. So wherever this opening is, that's the greater one. Does that answer your question? Okay, so yeah, that's a little alligator drawing there. Okay, moving on. So, okay, so basically it was just a little drawing for an alligator to help remember which one is greater than and which one is less than. It's like fractions are fun. Those are a couple little tricks that help sometimes. Okay. There's 2 more. So there's total. The total length, let's say. So what that means is the total length. So length 1 and length 2 is the total length. Or length 1, length 2, length 3, length 4, so on. So sum of the length and the width. So what that translates to is the sum of the length, so we'll call that L, and the sum, which means addition, of the width, and that's W. So those are some words for addition, just kind of zoom through them. They're pretty basic stuff. And as we go through problems, you start to be able to identify them more. Based on the problem itself, you usually be able to tell, like through the context, whether they want addition, subtraction, and so on. Okay, let's flip to multiplication. And then addition, or excuse me, division is only 3 words, I think so. So, here we go. A good thing about multiplication is like addition, it can go either order. So, 5 times the number. Yes, I will be sending these notes. So, just as long as you guys are understanding what's going on, and if I'm going too fast, just tell me, but it's just, I want to get through this quicker so we have more time to actually see how it's used in problems. So, okay, product. And then you guys can also start working on some stuff. So, the product of 3 and a number That's n times 3. I'm using n because the multiplication sign. I'll be sending all of these, these like words, and then it's quite a bit. It's like 18 pages, I think, right? So that's the majority. I won't be sending all the problems, but there'll definitely be some problems on there. So, okay, 3, okay, ignore the at one. You don't see at anywhere, so. If you do, I'm kind of confused about the problem writer, but if you see at, that's fine, it means multiplication, but you're not going to see that. Okay, double, triple, etc. You'll see those a lot. So if I say double a number, I'm saying take that number times 2. If I see triple, a number, that's n times 3. Quadruple, quintuple, sextuple, septuple, I think it's like 8-tuple or something like that, or octuple or something. So think of it as, well, not twins, but like triplets, quadruplets, quintuplets. It's those like root words you'll see, like the tri, quad, I think it's like cent or something like that for 5. So those are some keywords just to know in general. So twice. Twice the number. So twice is the same thing as times 2 or doubling. And then of. Or fractions. Okay, so of, or even fractions, yeah. Of a number. So if I say 3/4, derivative words. 3/4 of a number, that is 3/4 times y. And just know, you won't see it in competitions with star, but whenever, mostly like when you're typing mathematical equations, you'll see this asterisk. So it's the star thing as well. So that's multiplication. So remember when we did percentages, how we were saying 30% of, and I told you always look at the word of and think multiplication. So there you go. You guys see it again. Okay. Let's get through divisions and a couple other things, and then we can take a break. Then we can come back and start working on some other stuff. Okay, division. Quotient of. Okay, now this one's like subtraction. You really have to be careful of the order. So the quotient of 5 and a number. So the quotient of 5, so that's 5 and a number. So 5 divided by n. Half of, so whichever number comes first in the quotient of, like the difference between 5 and a number, so that was 5 minus n. Now the quotient of is the quotient of 5 and a number, so 5 divided by that number. So half of a number. So once again, this one is same thing as multiplication. Actually, see this of, so half times that number, but it's the same thing as saying that number divided by 2. So here we go. So you have half times n, but it's the same thing as saying n divided by 2. Okay, goes into. This one's a tricky one. A number goes into 6 twice. So what that means is a number goes into 6, so 6 divided by n is equal to 2. Let me see, number goes into 6. Alright, this one's kind of tricky. Some places will say it the other way. We'll look at some examples later and then we'll see. Because some problems go at 6 divided by n. Sometimes it's easier to think of it logically. Like 3 goes into 6 twice if you think about it. So that one's kind of iffy, but that's what you'll mostly see it as. So per, the price is $8 oops, per 50. So what that means is 8 divided by 50. Remember percent per 100, so we did something per 100, so something divided by 100. Okay. So, and then one that's not really related to, well, it is, but it's just equations. It's equals. So, equals means it is or is the same as, so you'll see like the equal sign in any of these ways. Gives, will be, was, is equivalent to, and so on. This is how you'll see that one. Okay. Okay, so why don't we take a quick 10-minute break? Might cut it short a little, like a minute or two. And then we can come back and start actually doing some problems. So. Okay, so why don't we take a break? And then you guys can come back in 10 minutes. Okay guys, let's get started. Is everyone here? Alright, if you guys could type that into the chat box, you guys are back. Okay, wonderful. Why don't we get started? So now we just head right into solving some equations then. Here's a little page I made that fractions are your friends, which they are. Okay, so just a quick 30-second thing. Okay, so the alligator mouth thing was I was just explaining how to tell which one is greater than and which one is less than. So if the alligator mouth, you can look at the sign, which is really just looks like this. It looks like this or like this, and sometimes you'll see the equal to sign underneath, so greater than or equal to, that's what it means. So whichever way the mouth is pointing is the greater value, so that's all that was. So. Okay, why don't we get started? Here we go. So I'm just going to start writing down some problems, and you guys can get started and type them into the chat box. So what I want you guys to do is write an algebraic, so that means an equation, expression for the following verbal expressions or phrases. Okay, 8 increased by a number. 2, 4 more than twice a number. So sometimes you're going to have to use multiple things like multiplication and division, or addition and something, subtraction. The difference of a number, and 5, the quotient of a number, and 2, and we'll do one more. 7 less than twice a number. Okay. So, why don't you guys get started, and then as you get them, just type them in the chat box. So I'll just start off with number 1. You guys, so number 1. 8 increased by a number. So you have 8, now increased by. So anything going up, getting bigger, is usually addition. So increase, so 8 increased by a number. So why don't you guys go ahead and start doing 2, 3, 4, and 5. And then you guys can just use for a number any variable you want. Let's just keep it to n for number. Okay, so number 2 is saying 4 more than twice the number. So this more than means plus. So more than, oops, is plus. Twice the number. Remember the twice? Oops. Okay. So this twice a number means multiplication. Okay, here we go. So, see this twice one right here. So basically what we're doing is it's saying 4 more, so 4 more, so that's the 4 plus, twice the number, 2 times n. So why don't you guys keep looking? So why don't you guys type in the answer for number 3. So what, basically your answer should look like an equation like this with some number n and some other numbers with either addition, subtraction, multiplication, or division, whatever the numbers or questions asking. So here, so it's the difference of a number and 5. So here we go. So there we go. That's the problem we're working on, and then you guys can use these to help you. And then also keep in mind subtraction includes. So here, I'll write it here actually. Okay. So I just want to see, why don't you guys type in the answer for this one using these. So what's the equation gonna look like? And even if you guys don't understand, you just try to make a guess. That way I can see whether you guys are understanding it or not. So, it could be wrong, just so long as it has n and a 5 in it, then you're almost there. So, I'll just wait for a couple more answers. So I want you guys to use this chart here, this operation and words chart, to see what is this problem asking for. So you just need to write an equation, something in a form like this. So how these are looking like n
You have what you try.
Okay, guys, you gotta try this problem. I just want to see like where we're at, because I know we went through the first part really fast, because I wanted to get to this part. So, what's the answer to number 3? So, type your answer for number 3. And it's okay if it's completely wrong or something like that. That's okay. I just want to see what you guys are guessing. So you guys gotta do this before we can move on. So. Okay, so that's a good step. So, but 3 is not division. Look here. So where do you see the word difference in one of these 4? And that'll give you a clue. Okay, so I'm seeing a little bit more answers. Still need all of you guys to answer. Doesn't matter if you guys write subtraction, addition, division, multiplication, doesn't matter. Just something. Anything goes. Okay, so you guys have figured out it's subtraction. Now how am I going to relate this number and 5 using subtraction? So what's this equation going to look like? It should look like, for example, if I have the words 3 plus 5, I would write it as 3 plus 5. Or if I have 3 plus a number, I would write it as 3 plus a number. So I want you guys to write this in something a form like this. Not necessarily plus, but something like this. Like I have 3, or in this case 5, so that's a start. I want some operation here, whether it be plus, minus, division, or multiplication, and n. Or it could look like this. It could look like n, and then one of those, and then a 5. So I want you guys to type that into the chat box. So I don't want to go on until I know that you guys are understanding this. So you guys need to make sure you put the answer in. Okay, so basically, I just want you guys to write this, so this expression here. So it's a verbal expression or a phrase. I want you guys to translate this into numbers and like symbols. So I guys give you a start. So it's either going to look like this or it's going to look like this. And then you guys just need to figure out which one of these, the plus, minus, division, or multiplication, is going to go in the middle. And that's all I want you guys to type into the chat box. So let's scroll this up again so you guys can see. Okay, so I'm seeing some answers, so that's good. Okay, so let me go ahead and move on. But I just want to make sure that all you guys are participating, so it's a big thing. So it's going to help you guys more if you guys are participating, because if I'm just going to solve the problem for you guys, it's not always going to help you that much. Whereas if you guys are actually going to solve it and then see where you guys yourselves made the mistake, that's how you're going to learn the best. So I just want to make sure you guys are doing that. Okay, so yeah. So you guys are on the right track. For the most part, you guys got it right. So it's saying the difference of a number and 5. So it is n minus 5. Because remember when we say subtraction and we're using the difference of or difference between, this first part comes, this a number will come first, and then the 5, and the subtraction sign in the middle. So if I were to say the difference of 5 and a number, then it would be 5 minus n. But because in the verbal expression, in this phrase, the word a number comes first, then in this expression, n has to come first. So does that make sense to everyone? How we got there? You guys could type it into the chat box, that'd be good. Okay. So, okay. So we do number 4. So I want you guys to go ahead and do number 4. So quotient, and then I'll just put this on the other side. So I want you guys to remember how we did how it was 5 and then n and then some operation in between. So I want you guys to do the same thing here for this one. So I want you guys to make that into some sort of equation with numbers and symbols. So quotient of a number and 2. So what does that mean? So the number is going to be n. Alright, so you guys could just type this in the chat box. It doesn't matter if you're wrong. It's just as if you guys just attempt it, that's all that matters. And I can show you guys where you guys are going wrong or something like that. It's only gonna help you guys more. And it's okay if you're wrong. I mean, we all make mistakes, so no one's gonna say anything because we all made some mistakes before, so we're all just learning this. Okay, so the quotient of, so here we go. When we look at this table, we'll find the quotient of is in division. So you know it has something to do with division, so we can put the division sign. So the quotient of a number and 2. So we know we also have to use n and 2. Now remember, like the division of like subtraction, the order in which they say it really matters. So in this case, when we say it using the quotient of, whichever part comes first will come first in this equation, so that's n. And the latter part, so in this case 2, will come after the division sign. So that's why it's n divided by 2. Does that make sense to everyone? So how we got, so first you find it in the table, then you put it before or after the equation. And if it isn't making sense or something, you guys can just type that in. And if you don't want everyone to see, you can just send a message to me only, and I'll be the only one to see it. So, okay. Then why don't we do number 5? Okay, so put number 5 here. So 7 less. Yeah, we can do more problems like these. Okay. Whoops. Okay. It was 7 less than twice a number. Copy this. And I'll paste it right here. So you guys can look at this table as you guys are working through it. Okay, here we go. So this one is going to use 2 different operations. Okay, so as you guys get them, just go ahead and type them. You already see some people are starting to do that, so that's good. Alright, so I'm just waiting for a couple more people to respond. And then okay. Here we go. So here's what we do. 1 second. Okay. So we have 7 less than twice the number. So here we go. Keyword. So we have 7. So we know we have to use 7. Less than. So we have to look where is less than. If you look here, you'll see less than is in subtraction. So we know we have to use subtraction. Now twice. Now what is this twice? Well, let's see. If we look here, so we don't see it anywhere here, so I can take it over. Okay, so twice. Where do we see twice in this list? We see twice in multiplication. So, we know we have to use multiplication. And a number, that's just add. So how do we put these symbols together? Well, we have twice the number, so we know that's going to be 2n. Oops, that's 2 times. So we know it's 2n. 7 less than. So that means 7 less than that. Does that make sense? And if you guys wrote n times 2 minus 7, that's perfectly fine. It's just sometimes easier to see than n. 2n minus 7. So does that make sense? How we translated it from 7 less than twice the number to 2n minus 7. And good job to those of you who attempted it. And if you got it right and wrong, that's great. If you got it right, that's absolutely fabulous. But still, it's really good if you guys are trying this problem and are willing to put it in the chat box. That's good. Okay. So let me do some more problems. Okay. Let's do I'll just leave it on this table here. Okay. Let's do one. This one's kind of tricky, so here, wait, let's just do this one. 5 less than a number. So what's that? You guys could type it into the chat box, that's good. That would be good. Okay, so I'm starting to see some answers. So basically what we have to do. So first we see the 5. So we know that's one symbol. And a number, well, that's our other symbol. Now what's this operation? So that's plus, minus, division, whatever. So, less than. Where do we see less than? Well, we see less than in subtraction. So we know you have to use a minus. Now remember in our key we were solving, so how did we interpret it? The less than was, well, we said 5 less than a number. So that's n minus 5. That's how it's interpreted. Like if I have, let's say I have some apples. So let's say I have 2 apples and someone has 7. I have 5 less than the number of apples they have. So they have 7 and I have 2. So I have 5 less than the number, so n is 7, the number of apples they have. Does that make sense? Why less than? You flip it. Okay, so why don't we do some more? I just want to make sure we really understand this, because if we're not going to get this, then we can't exactly move on. So, why don't we do the product? This is going to be used, it's a multi-step problem. So the product of 5 and x divided by the product of 6 and y. So what do we do there? So why don't you guys go ahead and look for that in the table, and then turn in your answers, or write your answers. Okay, I'm gonna switch it to here. Okay, you guys can keep typing in your answers, and here it is again. Okay, so go ahead and keep solving it. Okay, so I'm sending a poll out. So I want you guys to put in what you think is the right answer. So I put in some answers that are possible for this. So looking at the problem, what do you think is the answer? And then you just click on that. So all of you guys need to answer this. And if you guys can't see the problem, you can always move it around on your screen. So I want to know what each one of you guys are thinking. I want to make sure everyone answers. So go ahead, we'll take probably another 30 seconds to a minute to answer this. And you don't have to write it in the chat box for this one. Just go ahead and put it in on the poll. So I still have 2 people remaining, so if I could have those 2 people answer. Okay, 1 more to go. Okay, so I still got 1 more person. They could quickly answer as soon as possible. Okay, I'm still missing someone, so they could quickly answer. That'd be good, then we can move on. I'm just making sure everyone answered here. Okay, well, yeah, so from now on, for the answers, I'm just gonna put some answers up and then we'll do the poll. So that way, if you guys want to keep your answers private, then it's better, I think, that way. Okay, so actually it turns out okay, so everyone has answered. Okay, so the screen kind of froze there. Okay, so everyone did get the right answer, and it was option 2, which was 5x, whoops, 5x divided by 6y. So good job, you guys do know what you're doing, so, okay, so it's good. So you guys do are understanding. So let's do another problem or two. So yeah, instead of typing it into the chat box, I want you guys to answer the poll when I put it on. Okay, so here we go, 1 more, and then we'll start working with the equation. So 3 times a number decreased by 4. So don't type into the chat box. Okay, I'm glad you guys are liking it. So don't type into the chat box. Oops, can't talk. And then I'll send out the poll in a sec. here we go. Okay. Go ahead. So I put out the answers, and then you guys can go ahead and submit them. Yes, I'm still waiting for a couple people. Okay. So did everyone answer? Yes. Okay. So guys, most of you guys got it for the most part. You guys are just off by a little bit. Okay. So, 1 second, as soon as my computer finishes. Okay. So, the answer for this was option 4, which was 3x minus 4. So you guys are really close. Some of you guys said 4 minus 3x, which is, it's still really close. So you guys are on the right track for sure. So we got the 3 times the number, so that's 3x. We used x this time. Decreased by 4. So I don't have the subtraction ones up here, but when we say decrease by, we're subtracting 4. So if I have 4 apples, 4 blueberries, or 5, let's say, and I decrease this by 4, I'm taking 4 out. So 5 minus 4 then. Okay, so why don't we start doing this? So I'm going to start giving you guys equations with equal signs and whatnot, and then you guys can, and then I'll still put the polls to help, so you guys can type your answers in. Okay, and so if you guys are finding the polls easier, that's good. Okay, so the answer was 3x minus 4. Because it's 3 times the number, so 3 times x decreased by 4, so minus 4. Okay, so for example, let's say that I say the sum of twice, first I'm just going to show you guys how we do it, and then I'll start giving some sample sums. The sum of twice a number and 8 is 26. Find the number. So how do we do this? Well, the first part is just saying to write an equation for this. So now we're going to add, all we're doing is adding an equal sign. So just looking at this first part here, so that way, we have the sum of twice a number, so here's one word, the sum, and then twice a number, and then this and part for the sum is 26. So, twice the number, that's 2n. Now the sum of this 2n and 8 is, now remember is always equals. See, this is 26. So now all we have to do is the same thing we did in the last class. Just start solving this. So we subtract 8 from both sides. Get n is 18, and n equals, or 2n equals 18, and n equals 9. So does that make sense to everyone? So all we're doing is now we're taking it a step further. We're saying, so we have this verbal expression here. And now we're saying what it is equal to. Okay, so what we did is we have this verbal expression. So basically what we were doing before with these 8 added to a number, 3 greater than a number goes into 6 twice. So all we're doing is we're taking these expressions and we're just putting an equal sign after it. So I'll take the expression with equal sign. So this is, we're just taking an equal sign after it, and we're saying is equal to some number. And all we're doing now is then solving for this variable. So we're getting from, the main thing is getting from this step to this equation. And then once we get to the equation, I'm sure you guys know how to solve it by now. And if you don't worry, there's lots of practice. So that's what we're doing. So if that makes sense to everyone, what we're doing, we're taking these expressions, like the sum of twice a number and 8, and we're making an equation out of it, and then we're solving for this variable. Okay, so why don't we do some problems? Okay, yeah. Yep, okay. Glad it's making sense. Alright, so why don't we try doing some problems, and if it's still not making sense enough, we'll definitely go over each problem for sure. Okay. So, let's do the problem. 15 times the number decreased by the number is 42. Find the number. So there's a couple steps to this. First of all, you guys have to decode this first part. So, here we go. Let's try to make this a little longer. Okay. So, 15 times the number. This is your first part, decreased by the number. So you guys have to make an equation out of this, an expression. Okay, now is. What does is mean? We'll look at these 4 lists, and then don't forget the subtraction list. There's also subtraction. And then I'll put out a poll, so don't type the answers into the chat box. Is 42, so you know the 42 is there. And then I just want you guys to solve for the number. So, here we go. Why don't I make a poll for this? Okay. So class ends in about 17 minutes. So I want you guys to find what is n. So what does n equal? And then if you guys could put that in the poll, then we can figure that out. Okay, so only 2 more people to vote. So you guys can go ahead and do that. Actually, sorry, 3 more people. Alright, so still need 3 people to vote, I believe. Oh, okay, 1 more person. Okay, so everyone's voted. And would you look at that? Everyone's right. Good job, guys. Yes, the answer was 3. Okay, so why was it 3? Well, here you go. So you guys know what you guys are doing. Okay, that's great. Okay, so 15 times the number. So we have 15n. Decreased by the number, decreased by n, so minus n, is, so that's 42, you can see in the equals category. So now find n. So now we have this equation, all we need to do is solve for n. So we have 14n equals 42, and n equals 3. Does that make sense to everyone, how we got there? So hopefully you guys weren't just randomly closing your eyes and guessing an option, and you guys actually solved it. And if it's not making sense, just go ahead and tell me. Definitely be able to go back and take it a little slower or just review it again. So it isn't 15 because what we have to do is we're saying 15 times the number, so that's 15n. Now decrease by the number, so we have to decrease it by n, so minus n is, that's equal to 42. So now this is our equation, and now we have to solve this. So then we have to do 15n minus n, so that's 14n. Oh, what I said was 14n? So yeah, 14n equals 42, so n equals 3. Is that why I made the mistake? So it's 15n minus n, and that becomes 14n. Okay, so I want to make sure, yeah. So yeah, if I definitely make a mistake, go ahead and just tell me. I definitely want to fix that. Okay, so why don't we move on? I think you guys are getting this now, so that's really good. Here we go. Okay, so here's a long one. And then I'll put it in the poll again as soon as I finish typing it out. Okay. So don't forget your 5 categories here, and then I'll just add subtraction. Okay, so yeah, don't type your answers in the chat box, but in the poll. Okay, so here we go. Here's another one. The sum of half a number 3 times the number and 3 halves the number, or 3 halves of the number is equal to the number minus 20. This one's pretty long, but go ahead and take your time. So find the number. Just don't take extremely long. So, okay, here we go. So there's the problem, and then I'll make a poll for it, and then as you guys are looking through it, you guys can submit your answers there. Oops. So you should get in the form like something is equal to, and what is it equal to? So it should be a number. So this number n, we'll call it, is equal to what? Okay. Class comes in about 10 minutes. So I want you guys to work on the problem here. Okay, there you go. So I've submitted it, so go ahead and answer the poll. Kind of like voting, which is what most adults will be doing on Tuesday. Voting for the president. Okay, so go ahead and answer if you guys get it. It's kind of long, so. And then whenever you guys answer, we'll go through it. Okay, still need 3 more people to finish answering. There's only 9 minutes, guys, so make sure we get through this and then. Okay, 2 more people. And then we'll go through the answer. Solution, I should say. To words. Okay, 2 more people. So you guys haven't answered it, if you guys could do that, please. And then I've got the answers for those of you who already have. Okay, 1 more person to go. Okay, there we go. So, the answer for this one was, okay, my computer's frozen a bit. Okay, was -5. So how did we get there? Okay, so here we go. Just gonna bring this down a bit. So here we go. How do we do it? The sum of half a number. So half a number. So because we're talking about sum, the commas are representing where we put the pluses. So the sum of half a number, 3 times a number, and 3 halves of a number is equal to, so that's the equal sign, the number minus 20. So this is where all your phrases start coming in to play into this equation. So find the number. Well, we multiply the whole thing by 2 now. So we get n plus 3, oh my bad, 6n plus 3n equals 2n minus 40. So we add these all up, so we get 10n equals 2n minus 40. We want to bring all the n's on one side. So we'll bring the 2n over to the 10, so we get 8n equals -40. Now we divide both sides by 8. And then we get -40 divided by 8 is -5. So that's our answer. So it was option 3. Does that make sense to everyone, how we got there? Okay. Yeah, so it really comes down to now reading that problem and really analyzing, so what is it exactly asking? Okay, so why don't we move on? Okay, so let's do a word problem here, or 1 second. Okay, yeah, let's do a word problem now. Here we go. So it's 2, I'm trying to find, okay, here we go. Yeah, there's 5 more minutes. So I want to teach you guys this. So we have consecutive integer problems. So I want to quick teach you guys this, and then we'll do a problem on it. Here we go. So these are called consecutive integer problems. So here we go. So if I have consecutive integers, that means consecutive integers means the numbers go in order, like 1, 2, 3, 4, 5. They're right next to each other. So So will x be the first integer? Not necessarily 1. In this, whatever the problem is asking in that series, so x is the first one. Then, because they're integers, the second one will be x plus 1, third one x plus 2, and so on. Now, if we have consecutive even integers, it will be x will be the first one. Now, even integers go every 2, so x plus 4, and so on. Now, consecutive odd integers will go the same way as even, except x is just odd, because odd integers also go the same. Okay, so yeah, there's like 5 minutes left of class, but the time goes a little later in case we have to go like a minute. Okay, so in this one, just remember x is even, and this one, x is odd. Okay, so how does this play out in a problem? So that's just something you guys should know. So how do even integers and odd integers come out? Okay. So I'm just going to disable the chat for now, just to make sure you guys are focusing. I'll let you guys know when class is over, don't worry. I'm not going to keep you here all night. So. Okay, so the sum of 3 consecutive integers is 255. Find the integers. So basically, here we go. So just so you guys know, so some examples of consecutive integers is like 4, are here, 3, 4, 5, 6, and so on. Some even integers is like 2, 4, 6, and some odd ones are like 11, 13, and 15. So those are consecutive. They have to be right next to each other. So basically, in this one, the sum of 3 consecutive integers means they're all right next to each other. So we'll call them the first one x, the second one x plus 1, and the third one x plus 2. Now it's saying the sum of this, so that means we have to add all of these up. And that is equal to 255. And now what we have to do is we just have to group the like variables and solve the equation. So we have 3x's plus 3 equals 255. So 3x equals 252. So x is equal to 84. Does that make sense to everyone? So basically, what are these integers? Well, so x is 84. So the second integer has to be 85. So yeah, I will send the notes. So 84, 85, and 86 are the 3 integers. Does that make sense to everyone? How we got there? Okay, fabulous. So what I want you guys to do is I want you guys to solve this problem, and I'll just work alongside with you guys. So, let's take the sum of 3 consecutive odd integers, capitalize that so you guys don't miss this. So I'll explain this again in this problem, is 381. Find the integers. So odd integers go up by every 2. So we start with an odd one, and then the next odd number is 5, the next odd one is 7. So you'll notice if we call the first odd integer x, the next consecutive odd integer is 2 plus that. The next one is 2 plus that. So we need to find the sum of 3 consecutive odd integers. So we'll let the first odd integer be x, the second one be x plus 2, and the third one be x plus 4. So they're saying the sum of this. So the sum, you have to add them all up. And that is equal to 381. So now we just have to solve this equation. So what we do is we just group all the x's together, so we get 3x. So we group the other 2 and 4, so we get 6 is equal to 381. So we get 3x is equal to 375, and x is equal to 125. That ends. Okay, so we know the first odd integer is 125. So the next odd integer after that is 127, and the third is 129. So if you add all these up, you'll get 381. So does that make sense to everyone? That one went kind of fast, but you guys can look at the work. You might be able to, you'll follow how we got there. Okay, so then anyone have any questions on anything? Last week's homework or something? So I found the homework for this week, the solutions for last week, and the notes. So. Okay, well, great job today, guys. See you guys next week then.